Welcome. This video describes the parameters for an independent voltage source in LTspice. Using the pulse option to get a pulse train voltage signal. Place a voltage source on the LTspice schematic. Type V to bring up voltage source in placement mode. Left-click to locate the source on the schematic, and then click Escape to clear the placement mode. Right-click on the source to bring up the menu, and then click on Advanced to get this detailed menu showing functions. Select the Pulse Radio button. The main goal and purpose of this video will be to explore and describe these parameters in detail. Fill in the values as shown. The small s for seconds is optional. Click OK. Save the file. Run the simulation. Click on the VIN node in the schematic to plot VIN, the pulse train source voltage.
This is a schematic and transient simulation result for the pulse voltage source parameters we just specified. Let's look at the parameters of a pulse voltage source in detail.
The V initial parameter is the starting value of the voltage, 0 volts in this example. The V initial parameter is also referred to as V1 in general SPICE syntax. V on is the on voltage, the value of the signal after the pulse is turned on. V on is 1 volt in this example. The V on parameter is also referred to as V2 in general SPICE syntax. V on does not need to be larger than V initial. Tdelay is the delay time from 0 until the pulse changes from V initial to V on. Tdelay is half of a microsecond in this example. Trise and Tfall, the 2 nanosecond rise time and the 2 nanosecond fall time, are too small to see clearly on this plot scale. We'll come back to rise and fall times. T on is the duration of the time that the signal is turned on, 1 microsecond in this example. P period is the period of the signal. After this time, 2 microseconds in this example, the pattern repeats. The Ncycles parameter specifies how many pulse periods the voltage source will produce, 3 in this example. We can see that after 3 periods, the voltage source stays at 0 for the remainder of the transient analysis. If you want the voltage pulse signal to continue to repeat, set Ncycles to 0. To get a good view of rise and fall times, let's look at a new voltage source example with 0.4 microseconds rise time and 0.3 microseconds fall time. Trise is the rise time, the amount of time it takes for the signal to go from V initial to V on. Tfall is the fall time, the time it takes for the signal to return from V on to V initial. One final note: Tdelay, the initial delay time, is not part of the period of the signal. If this is not clear or convincing to you, try some simulation experiments yourself to verify your understanding.
For circuit theory analysis of RC pulse train response and other RC, RL, and RLC circuits in time and frequency domain, please see this book, First and Second Order Circuits and Equations, available from John Wiley & Sons. There is a link in the video description.
Thank you for watching and learning with us.